We all know there are periodic solutions, right? We actually have found some periodic solutions even for turbulent flows. I mean, they are non-trivial to find, but we found them. There is also another set of quasi-physical solutions. That's something highly difficult to find. I mean, they are even more difficult to find than periodic solutions. And I'm just starting to discover kind of the tip of the iceberg of these quasi-physical solutions. So let me explain that. This is a set of periodic solutions for the Lorenz equation. And if you looked deeply into the Lorenz equation, you probably have already seen that in many literature. So, for example, there is one periodic solution represented by the solid line that loops over the attractor in the infinite loop, right? It's just a figure 8 loop. If you look at the dashed line, right, the dashed line actually loops over the left for 2 periods, and then it goes towards the right for another 2 periods. And there is also the dotted line that goes on the left 3 times and then goes on the right 3 times. So it turns out there is an infinite set of periodic solutions. And of course, here you may ask, how did I find these periodic solutions? And I mean, in general, it's hard, but for Lorenz equation, it's actually easy because Edward Lorenz himself have discovered a very interesting thing about the Lorenz equation. That's if you know what is the local maximum of the y-axis, or actually the z variable, at one loop, that is a very good indicator of what is the next maximum, local maximum of the z coordinate. And you can construct a map, actually called the Lorenz map, from one maximum z to the immediately next maximum z. And this map looks something like this. So this is a map constructed by Edward Lorenz himself. Now, if you intersect this map with a diagonal line, this point, right, this point maps one maximum z to the same maximum z in the next loop. So this is exactly the solid line, right? If you look at the solid line, one maximum z, you go to the maximum z on the other side, on the symmetric side. So it's going to be the same maximum z. And this is how you can easily find one periodic solution of the Lorenz equation. Now, if you plot the z versus the maximum z, two maximums ahead, 2 loops ahead, right? Or the iterated map of the Lorenz map, and then do an intersection. So first of all, you get the same intersection from the last time, but you get 2 additional intersections, and these are the dashed lines. And if you can do this to the 3 times iterated map, and you get the dotted line. So it is easy for Lorenz equation.